Picture this. Mozart is 8 years old, barely tall enough to see over the piano, and yet he's already composing music so good it still gets played today. Meanwhile, a young Richard Feynman is sitting in his bedroom fixing radios for fun, and solving electrical problems trained engineers can't even figure out. Two completely different worlds, music and physics. Yet the same impossible question comes up. Why are these kids so far ahead of everybody else? And what makes them that way? Is it magic? Is it destiny? Or is it the way that their brains are wired, the chemistry, the learning circuits, the reward systems? What makes their brains make them be able to do what normal people can't do? Today I'm going to break down why their brains really worked, and what the science says about musical prodigies, and why them in particular become world-class musicians before they even reach puberty. So without further ado, let's get straight into it. First of all, let's talk about the secret fuel that drives almost every single prodigious brain. Dopamine. Now, when most people hear dopamine, they think of feeling good or happiness. But that's not really what dopamine is. Dopamine is your brain's achievement chemical. It spikes when you anticipate progress, like when something feels rewarding to learn. Prodigies have dopamine circuits that are way more sensitive than our own. Like when Mozart practiced, he wasn't just playing and enjoying it, his brain was quite literally lighting up. And his reward center was going off more than a fat kid in a candy store, or a virgin at a GameStop. This means two huge things for musical prodigies. One, practice feels intrinsically good. It's not boring, it's not repetitive, and it is genuinely rewarding to them. And two, they stay in the practice zone for way longer than we do. Hours can pass without them realizing it, and they just play and play and play and play and play. Most people get frustrated when a passage is hard. But Prodigy, their brain literally rewards them for trying again and again. And it's not just talent, it is chemistry. It's the brain saying, yes, yes, do way more of that. This dopamine sensitivity is one of the biggest things separating a prodigy brain from a normal brain, because their brain biologically rewards the behaviour that leads and creates to mastery. Second of all, GABA, the precision chemical. Precision, the precision chemical. Now it can be pronounced GABA or GABA, I'll be saying GABA just to make it easier. And it's fascinating, because while dopamine explains why people get obsessed with practicing, especially prodigies, GABA explains how they get so clean and precise so early. GABA is the brain's main inhibitory neurotransmitter. It doesn't just speed things up, it filters things out, as opposed to an excitatory neurotransmitter, which we'll get into later. Imagine you're in a crowded room, and everyone is shouting different things at you. It's going to be pretty difficult to concentrate. And that's like your untrained motor cortex, which we spoke about in this video. Now imagine you put on noise-cancelling headphones. Think how much easier it would be for you to focus then. It reduces the neural noise that you have in your brain, so you can focus on what you actually need to focus on. In this case, the exact motor commands and sequences you need to actually play the guitar. In prodigies, GABA behaves really differently as opposed to a normal person. Studies show that prodigies often have high GABA efficiency, cleaner motor cortex signaling, and stronger inhibition in fine motor circuits. This means when they try to learn something that's really difficult, their brain is sending a much cleaner, sharper, and stable signal. Much like in my previous video, it's like comparing copper wires to high-speed fibre optic cables, which again I can say now. It's the same signal, but it's much more clear. Now, why does this matter to musicians so much? Think about the technical skills that musicians need to develop to be good at their instrument. They need the finger independence, the timing, the picking accuracy, the fine motor controls, and all of these rely on precise inhibition, not just excitation, which again we'll get onto in a second. You don't want every muscle firing at once, you want specific muscles firing at specific times to create the sounds that you want. Nothing else. Now, talking about prodigies, they have GABA systems that are unusually good at shutting down unnecessary movements, stabilizing their small muscles, cleaning up timing errors and suppressing the extra noise that's in the motor cortex. This is why young prodigies can play something incredibly complex incredibly cleanly, even before their hands are fully grown. Now what else can GABA do? GABA doesn't just make movements easier, it makes them learnable. When your motor cortex is noisy, every single repetition that you do will be slightly different, and that's inherent, that's human. But your brain can't figure out what it's trying to reach. But when the GABA is strong and efficient, every repetition is consistent, muscle memory forms a lot faster, timing locks in much sooner, and mistakes get corrected much easier. It's not the fact that we're born knowing the technique, it's that our brain is wired to stabilize this technique a lot faster than a normal person. So while dopamine explains the obsession, GABA explains how they can get so precise. Prodigies don't just become obsessed with more and more and more and more practice. Their brains are literally better at clearing up signals and turning their movement into actual music. Next up is the extreme acceleration of the learning. Why do prodigies learn significantly faster than everybody else? Like, I'm not just talking a bit quicker, but weeks of progress in days. Years of techniques in a couple of months. It comes down to the acceleration trio. Now, I don't know if it's actually called the acceleration trio, that's just what I kind of call them because there's 3 of them, and it's learning acceleration. But anyways, I digress. The acceleration trio is made up of glutamate, NMDA receptors, and BDNF. These 3 chemicals work together to control how fast the brain can form these new connections, and in prodigies they run at turbo speeds, as you would expect. Glutamate is the brain's spark plug. Glutamate is the brain's main excitatory neurotransmitter. Think of it as the electrical spark when neurons communicate. Every time you learn a new chord or a scale, or train a new shape, glutamate is right there triggering the circuitry. In prodigies, as you'd probably expect, glutamate is unusually effective. The spark is brighter, faster, and way more coordinated. This means information travels way more smoothly, motor patterns solidify significantly quicker, and new skills become stable much sooner. It's like your brain is already wired to light up. Next, NMDA receptors. 4 letters that I cannot say quickly next to each other. These are the safe buttons for learning. NMDA receptors are the brain's learning receptors. They're the ones responsible for synaptic plasticity, which is a strengthening of connections between neurons in the brain. If glutamate is a spark, then NMDA is like the yes, save that quick button. But to learn absolutely anything, not even just music related, NMDA receptors need to activate. And in prodigies, as you would expect, they activate much faster, respond strongly, and stay for much longer. This gives prodigies much stronger memory consolidation and incredibly fast pattern recognition. Just like if I were to say 13% of the notes make up 50% of the issue. I mean music. This is why young prodigies can remember things so damn quick. Their brain's save button is incredibly sensitive. But anyways, the third attribute of the learning trio, BDNF, something I can say much easier than NMDA. NMDA. This is the brain's fertilizer for growth. BDNF stands for the brain-derived neurotrophic factor, and this stuff is like miracle grow for your neurons. It strengthens your synapses, helps them grow, protects them from stress, and accelerates the long-term learning. And believe it or not, in prodigies, BDNF is much more readily available in the prodigy brain. The brain releases much more of it during practice, and the motor cortex is much more sensitive to it than a normal person. This creates a brain that actively wants to change itself when it practices. But anyways, now we know what all 3 of them are, how do they work together? When a prodigy practices, glutamate first fires in the neural signals. Then the NMDA receptors grab those signals and then turn them into long-term learning. And then lastly, the BDNF strengthens and practices those new connections. It's a perfectly synchronized system. This is why prodigies pick up things much quicker, learn things much faster, remember a lot more, and improve at a pace that normal people can't even try to keep up with. And that biological advantage adds up and compounds over time significantly. Next up, let's talk about the electrical engineer behind the talent, the neural wiring. Now, when you hear someone say, oh yeah, their brain's wired differently, when talking about someone who's really good at something, that's not all just a myth. Their brains are literally different from normal people's. When a normal person learns something, they obviously get frustrated, they have to learn it, they have to go through it multiple times to get it good. But a prodigy does the exact same thing, but with fewer synapses, which means less resistance, which means faster communication, which means faster learning. It's like their brain is composed of fiber optic cables, which I can say now, because I practiced. Scientific studies found that in prodigy brains, there is denser white matter within the brain, more efficient connectivity, and less signal loss. This lets prodigies not only learn the skills faster, but lock them in permanently. Now, another thing that contributes in terms of wiring is the auditory cortex, something we didn't talk about last video. Musical prodigies consistently show a more active auditory cortex, as you could probably figure. They had more specialized tone processing neurons, which if you couldn't tell is a neuron that processes tone, and a greater sensitivity to things like pitch and timing. So their brains aren't just listening to it, but they're actually analysing it as they give it a listen. Now, plasticity. Again, we talked about this in a previous video. But the prodigious brain stays in a hyperplastic state for significantly longer than a normal person's. Most people's neuroplasticity, if you look on this graph, peaks around early childhood and ramps down quickly. but prodigies keep that plasticity switched on high pretty much constantly. This is why Mozart could listen to a piece and just write it down instantly. His brain wasn't just hearing it, he was actively imprinting it onto his mind.
Will you marry me, yes or no?
So finally, after all this time, there's a real question. Are prodigies born or are they made? Well, to be honest, the scientific answer is a little bit blurry because, well, they can be made, they can be born. But not in the way that most people think. Prodigies don't just pop out the womb speaking 100 languages or, I don't know, playing some Paganini. Because you can't fit a guitar or a violin up in there. I'm sure someone's tried. But what prodigies are born with is a brain that's hyper-optimized to learn. Hyper-efficient wiring, fast learning circuits, intense dopamine responses, massive pattern recognition, huge working memory, and crazy neuroplasticity so early on in life. And these traits are like the soil. But the soil isn't what makes a tree, it's a seed that you put in it. But in this case, the tree grows because of the timing, the practice, the repetition, the countless of hours that we don't always see when we're watching videos of them. But all of these hours of practice occurred when the brain was most vulnerable to change. But prodigies aren't just miracles by themselves, it's a combination. With rare brain advantages, and an environment that really pushes them to strive to be perfect. Usually, they're able to become perfect. But just remember, adult brains can achieve significant amount of growth too. Your brain will always be plastic, it'll always be able to rewire, and reshape and upgrade your musical ability. But it just has to take a different road to what we see online. But the destination is still somewhat possible, even if it's not that extreme. But just remember, when you shoot to the moon and you miss, you're probably going to freeze to death because space is very cold. But at the end of the day, it's night. And remember, always count your chickens before they hatch, because that's when you get the highest numbers. And I'll see you in the next video, so subscribe, like, and I'll see you in the next one. Bye bye.